everyone who worked on something can have maybe around 5 minutes to show off what they did this hackathon. So can we sort of get a show of hands of who is interested in showing something, so we can estimate how many? Okay, so okay, yeah. So we're gonna give around 5 minutes per project, I think, and I'll show you like a 2-minute warning when we get too close. We're not gonna make a queue because it would be quite annoying to stand there for almost an hour. So it's sort of first come, first serve basis. Who would like to start?
By the way, we only have an HDMI interface here, so if you need an adapter, get ready with the adapter and charge your notebooks and all that.
Okay, thank you.
Someone in the front has a USB-C HDMI adapter.
Great. Okay.
A mini display port adapter is also there. Thanks. Thanks. Remember to take it.
Okay. There will be 2 of us. Okay, so this is the Green project, which is a code generator for lazy languages. So this weekend we worked on a couple of things. A couple of people joined us and helped. Thanks for them. And also some interesting results happened. Like we have an Agda front-end sketch. So the Green is language agnostic. It can be used for Haskell and for other languages. And for now, we have an Idris front-end work in progress, and now we have an Agda front-end work in progress. And also we will have a GHC. But anyway, so this weekend, these things happen. Thanks for the Nix support. For now, from now, you can try this system on Nix. And we also Daniel also implemented a confluence test, which helps for testing the code generator pipeline, because the transformations need to be confluent. So we always had to get the same result, no matter what order we apply the transformations. And an improvement were done on pretty printing after we linked the Green code. So let me do the demo. So this is an example of the pretty printing and the linting. Yeah, I think good tooling is very helpful if you develop compilers, because errors always happen, and let's just make the debugging as easy as possible.
Yeah, so Csaba didn't want to talk about this, so I will. I worked on the confluence test tool. So basically, I just joined the team for this weekend, and I asked for a ramp up kind of task. So what I did was trying to apply a list of transformations twice with different permutation on the same code, and see if the resulting code basically produces any diffs. Like, is there any diff between the two transformed pieces of codes? And that shouldn't happen if the transformations are confluent. Turns out it happens. So 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 that was a unit test, and then I worked on some tooling to actually expose this functionality through the command line interface, so that you can run this against any piece of code, any piece of green code, and then basically run this test as far as you bump into an issue, and then it will dump you the diff between the two resulting expressions, nicely pretty printed, the actual diff, and then it also tells you what was the actual permutation of transformations used in the first and the second case, so that you can reproduce this problematic test case.
Okay. Let me show what happened. So let me show a demo of the system. Let's imagine that we want to compile this simple program, and actually this is the green version of this Haskell code. The red operators, the red commands are building the tongues, and so they are heap operations, and the underscore prim function calls are the primitive operations. So this is just looks like a do notation, but this is green language, which is a monadic language for now. So anyway, I just pass this program to the compiler. It will infer the types of the memory, the heap location, and the variables. So the numbers are actually pointers with distinguished content. So that's this result. This is the result of the global program analysis, and then we can generate machine code from that, which is quite long because this is the non-optimized version, and the system also runs it with using LLVM HS. So that's the result, as you can see, and the system is able to optimize, apply certain optimizations, transformations on this, and getting this tinier program as a result. And if we compile it to machine code and run, we have the same result, but the LLV using green and LLVM, the LLVM managed to compile to constant, which is nice. So that's it. Okay, next.
Thank you. One, two, three. Good. So in the Frege project, which is in Haskell for the JVM, we looked into various pieces, first in a beginner style, and saw what you can do with it. One of the many things is making graphical user interfaces. If I can click the start. So this is JavaFX. It's the Java way of making desktop UIs. And but you can use it from Frege, which is a Haskell, so you get the Haskell experience and lots of interesting characteristics. For example, you can no longer make your threading wrong, which is a typical error that you do when you're using JavaFX from Java. And you might recognize this picture, right? Okay. So this morning, we had seen that there might be problems with a lazy language, and Frege is as lazy as Haskell. And when you run it on just general purpose garbage collector. So we actually looked into this by looking into this kind of code. So what we do is we are mapping FST over X and some lazy evaluated thing of x, a thunk, from 1 to 10 million. And then forget all the second part of the tuple and adding up the first part, right? So this should leave no objects behind, no artifacts behind on the heap. And then we're just waiting for the program to start such that we can use the Java tooling, the Java memory profiler to hook onto it, which we then did, then executed the foo, then waited again, such that we can use the garbage collector, see what the garbage collector does, and then return. Clear so far? Is that okay as a test? Oh, good. So this is what we saw. This is all of the heap. This is the used heap. So first you're kind of exhausting almost the heap, and then you wait when you're finished, but when you issue the garbage collector, it goes back to 0.
So I'm the maintainer of LVMHS together with Steven. We don't really have any exciting demos, so I'm just going to go through the work that we and most importantly the new contributors did. So I think we managed to attract 4 new contributors, so that's pretty exciting. Rick has been adding a new example to the LVM examples repo, which is really useful. That it contains a bunch of small examples that help you get started. Someone has been working on migrating the Pretty Printer library to David's new Pretty Printer library. Not sure if you've seen it, but it's sort of like encompasses all the various changes that the various pretty printing libraries have been making, and it's kind of adapts to modern Haskell, so that's pretty nice. We now have bindings for loading object files that you've compiled externally using GCC or whatever compiler into the JIT compiler, and then you can look up symbols and call functions in these object files. Someone has been working on the typed IR builder stuff that Steven has been talking about in his keynote, and has been getting started on that. What else do we have? So LVM has a new pass manager that we don't yet support in LVMHS. And I've started work on that together with Matthias, not sure if he's around. So we didn't quite finish that, but at least we got somewhere along the way. I've also worked on better error handling in the JIT compiler. So now if you have symbol resolution failures, you actually get a proper error and don't just end up calling null pointers, which can be quite confusing. I've also added some documentation, so now it should be a lot easier to get started. You have this nice overview of the various libraries that we have in LVMHS and how they relate to each other, and sort of for the basic overview of the most common tasks. And yeah, that was so. Thanks.
Hi, I'm Mark. I'm still learning Haskell, and I'm working on a way to generate bokeh plots. So what is bokeh? Bokeh is a data visualization library. It's very powerful, as you can see in the slide. You can make some really nice plots with it. And even cooler, plots are described through a typed DSL, the serialized to JSON. And when you hear the words typed DSL, I wonder what we all think of. Bokeh officially supports only Python and JavaScript, but as long as we can generate the serialized JSON that describes the plots, we can use any language. So why Haskell? This is some bokeh code written in Python, and just going through it, we can see that we can make a lot of this stuff into ADTs. They give us some type safety. So range 1D, that's just the product of two numbers. Plot, that can be made into a record. And right under that, we have plot.addLayout. And the second argument to that is below, which is a string. And the only valid values for this are above, below, left, right, and center. So making this a string is not really a good idea. I don't want my 1 hour data pipeline to abort because I misspelled the word left. So we can really take advantage of Bokeh's typing in its DSL by writing stuff in Haskell. So that way, we don't have to do the type checking at runtime. We can do the type checking at compile time. So my goal for Zuri Hack was to make a way to generate the JSON type safely and let Bokeh do the plotting. Bokeh's plot DSL is massive. Yeah, that's a picture of it on the slide. And I had almost nothing coming into Zuri Hack. So I had pretty small goals. One is to write enough of a Haskell EDSL to represent a simple line plot, and two, write a function to compile this to Bokeh compliant JSON. And here it is. This is the library in action. This top thing right here is me describing the data frame. This is actually not that safe. I'll go into it later. And below is safe, and this is me describing the size of the plot, and the layouts of everything. As you can see, instead of left, we have B left. Instead of below, we have B below. And this is caught by the compiler if I misspell any of this stuff. And that outputs this JSON. It's like 300 lines. And yeah, it's basically a large collection of string-typed objects. And if we put this into an HTML page and include the Bokeh rendering JavaScript file, we can turn it into a plot, which is what this script does. Yeah. So yeah, I think this is a pretty successful Zuri Hack project in my opinion. And next steps would be to extend this library to take advantage of all of Bokeh's features. I'm aiming for something that's about as easy to use and powerful as the Python library, while still having the type safety of Haskell. I'd like to create more convenient functions for making the plot, as opposed to just writing out the ADTs by hand. And the last thing, the current way I store data is as an associative array of text and arrays of numbers. And this is actually pretty unsafe, because if I refer to a field, it's not actually guaranteed to exist in this data frame. So if you know a way that I can verify that the fields are actually in the data and they're all the same length, please ping me in the Slack. Yeah, that's it. Thank you.
You got that one. Okay, so I spent the weekend working with Matthew Pickering on this little library called Assert Explainer, and the idea is to give you a way to explain assertions using GHC source plugins. So the library itself is pretty simple. I just give you one function here, IO, that takes a Boolean and is IO unit, so it doesn't really do much. And in this case, you give it length x's, and x's doesn't happen to have length 4, then you get an assertion failure. So if you were to integrate that into a test suite, it's really saying that your test suite just says, no, that assertion doesn't hold. But if you don't have this in a test suite, and we're actually doing this in some kind of
it's a runtime assertion in a production server, then we just get assertion failed, which doesn't really tell us any information as to why that assertion failed. It's a little too late at this point to go in and do any debugging because I've lost all the context that caused this assertion to fail. So my goal was to write this library called assert explainer, which actually shows you why an assertion hasn't hold. So why is that Boolean false rather than true? So this is a little example that I put together. Here you can see examples 1 to 4, just calling this assert function. And then in main, I'm sequencing these all together and just using getchar as a little pause. So if I cabal new run on this, yeah, that's all there. Okay, so example 1, we can see assert true. We would hope that's fine. Oh, sorry, it's actually showing example 2. Example 1 was fine. It's, example 2, assert failed, assert failed, assert failed. So we got a call stack there, so I can kind of go into the source code and work out whereabouts this assertion was actually called, but it doesn't really tell me what went wrong there. So with GHC source plugins, however, I can just add one line to my file, or I could put this in the cabal file. It's right at the top there. I just enable the assert explainer plugin. And if I save that and rerun the tests, okay, so there we can see that the first assertion there, true equals true, and I get the line number, which is not particularly interesting. I'd kind of hope that true does equal true. And on the second example, we're just asserting false. So I would expect that assertion to not hold. And I get assertion failed because false is not true. Which again, this isn't particularly interesting. Now things do get more interesting in example 3, because here we've got that original example that I saw in the slides, where I'm asserting that length x is 4, and we can clearly see that x does not have length 4. So if we run this through assert explainer, it actually now does some sub-expression analysis on the source code that was passed into assert to help you understand why that assertion didn't hold. So you can see here the assertion is actually inlined into the runtime, so I can see what I'm asserting. And then I also see all of the sub-expressions within that expression that I can show to try and understand why that assertion didn't hold. And this really scales to kind of anything that you can write that produces a Boolean. So in example 4, I'm asserting that the character Z is in the uppercase of this string concatenation. And if that isn't holding, it might be a little difficult to work out why it doesn't hold. Again, we can just run that through assert explainer, and I now get all of the kind of sub-expressions that were in that assertion to understand why that assertion didn't hold. So I think this is pretty cool. Like, you wouldn't be able to do this normally in GHC because I'm actually at runtime kind of inspecting the source code that went in to produce this. So this is done with a source plugin. I was going to show some of the code that runs through it, but it's not particularly nice to look at. But the general idea is my plugin runs after type checking. I find any occurrences of this assert symbol, and then I can look at the actual source code that gets applied to it. After that, I can find all of the sub-expressions in the expression that was given to assert. I can run that through the type checker, work out which of those are showable, and then basically replace the assert statement with a bunch of print statements and case analyses on those sub-expressions to see the individual steps here. So there we can see Z is the character Z. We can see that the concatenation of two strings is high zeri-hack. We can see the effect of map to upper over those. And that's all stuff that's going to be happening at runtime. So that was a kind of proof of concept over the weekend. I'd actually like to take this just a little bit further and kind of present this in more of a like equational reasoning substitution layout. So here, if we take that last example, what I'd really like to say is, here's your original assertion, and here are some substitutions I can make based on the data I've got at runtime that eventually proves why the assertion is false. So this is all on GitHub. You can get it on my GitHub if you want to play around with this. It's just called Assert Explainer on my GitHub page. You will need GHC 8.6 though, so it'll take you about 4 hours until you can start playing with this, unfortunately. Yeah, that's it. Thank you very much.
All right, so I've been working on this template engine called Ginger. It's an implementation of the Ginger 2 HTML template language for Python, and it's basically a Haskell clone of that, and this is what a template looks like. When I came here, I had a list of, I think it was 6 things that I wanted to work on, and now I have like 11 open tickets. But that's actually great because I've had quite a bit of interest from people here, and they made all sorts of great suggestions and actually solved a few issues and contributed. So that's pretty great, and many thanks for that. Yeah, good question. I'll get into this in a minute, or actually I could actually get into this right now. So the target audience here is essentially web developers, so not necessarily coders, and that explains a lot of the design decisions here. One of them being that it has to be a language that is already familiar to web development people, so that's why I picked Ginger in the first place. But there's also this very realistic use case where you have to build something that has to run on some cheap shared hosting service, and those tend to not really allow Haskell. And besides, I don't want users to necessarily have to learn Haskell. So compiling to PHP is one of the things I might want or not in the future. But generally, I have this idea that I want to provide a compilation mode so that you can somehow compile templates into something that you can either bake into your binary or ship to a PHP thing or whatever. And part of that effort is optimization, obviously. So that's something I've been working on in order to optimize our templates at compile time. One thing I want to do, or that I'm already doing but badly, is to look at the entire parsed AST and then figure out which parts are already fully known at compile time and reduce them to whatever they evaluate to, so that I can just bake the simpler value into the template instead of having it all run at runtime when I already know what it's going to evaluate to. So the problem is that Ginger is a highly dynamic language, and it's even worse because the dynamicness of it is even influenced by the host application. So when I have a template, I can't infer all the information from the template alone. I have to know what kind of stuff gets passed in from the host application. So for example, in order to make this analysis, I have to know about functions, whether they are pure or not. So given that a function is pure and that all its inputs are statically known, I can infer that the output is also statically known. But for that, I need to know all the inputs and all the functions, and I don't. So I actually thought it was impossible to do that, but then somebody, can't remember who it was, but hinted that I might be able to pull it off after all if I were to express it in a way that, given these properties on the inputs, we can derive these constraints on the template and on the outputs. So that's essentially what I've been working on now, is a constraint analyzer that takes an extra input that tells it the current context in which it runs, and as long as those promises are kept, I can actually make these valid reductions. And unfortunately, I haven't managed to finish it yet, but I've gotten quite a way. So here on the right, we see the code that does most of the inference. It's pretty straightforward, actually. So it has this monad that tracks evidence, and the evidence type just tells us, is essentially just a map of scope items to constraints. It's really quite simple. So each constraint can tell us whether the thing we're looking at is statically known, whether it's a pure function, whether we actually know the value and what that value is, and whether we know what it outputs. And we can combine these constraints things, and we can combine these evidence maps in all sorts of interesting ways. And that's what these infer functions do. And they track the containing evidence in the infer monad, and they return the evidence that is particular to the thing we're looking at. And then we combine them in all sorts of ways. And then we can, I've written a little helper, we can pass a template like this into the analyzer. So here we're setting the foo variable to the static value hello, and then we're interpolating that the value of the variable foo into the context, or into the output, sorry. And the analyzer correctly establishes that the output is indeed static, and that it's hello, literally, and that the return value is also hello. And if I do it without this set, and I don't give it any additional information, then it says, hey, I don't know. We don't know anything about this. So it's actually kind of working already, and it's not complete yet, but I'm pretty confident that I can actually pull it off. So that's nice. Any questions? All right.
Yeah, sure. Yeah, hi. So I'm Toby and this is Oscar, and we set out to do a bit of work on documentation. So we figured why not do some documentation for MTL. And so we had a short chat with Ed, and he was fine with that. So he was basically, hey, if I don't have to do it, fantastic. And so what we started with is that we sat down and wanted to give a nice entry point to the package, and we started working on making the README like a nice place where people can get an overview on what MTL is all about.
Yeah, so what you see here is first an issue kind of outlining the current state of the documentation of MTL in Hackage and on GitHub and so on, and also a bit on the wiki. So yeah, as Toby said, we decided to focus on the README part so far, but there are more things in here that we can continue working on later. So things like FAQs or different considerations, making the haddock headers and documentation better, and so on.
Yeah, I mean, I guess it's not exactly glorious and fascinating, but at the same time, documentation never is until you actually need it, and then have a really good time because it's there. And so one thing that we also started to wonder about is if it's possible to think about what kind of standards or guidelines we could set up or like as a community agree on, like not forcing everyone to do anything a specific way, or like to force anyone to have any specific tools or whatever, but maybe to set out some sort of base guidelines on how to document your project, so that everyone is can have a nice time exploring your stuff and find out how it actually works. Yeah, well, that's future stuff.
Okay, and yeah, today after much confusion, I can tell you that if nothing else comes from this, I thought I knew MTL before, but I really didn't. So now I have a vague understanding. So if you want to learn a package, then try to document it. It's great. But we managed to get a PR in. So this was the README before, and yeah, now there's some stuff. So there's a little overview of the structure, how it works, and its relation to transformers, a bit about lifting, and then the actual transformers and their classes, kind of outlining the purpose of each thing here, and a bunch of links in the bottom. So yeah, we didn't want to do like links into haddock from here because they can go stale and diverge from with versions and so on. But this is something that if you don't know at all what MTL is, I guess this will help a bit. Yeah, and then we'll see in the future what more we can do. We have some other ideas on this specific package, but I hope we can. We wanted to add a motivation section, like before the structure, have a very non-technical motivation description of this package. I think that's almost the most important one, but also the hardest one to write. So we'll see about that. Yeah, and that's us. Thanks.
So every year we try to do something interactive and silly. This year is no exception, but I have no idea if this will work. So, because it really involves you. So if it doesn't work, yeah, forgive us. That's okay. This seems to work. Everybody do like a relatively low note, like oh. Okay, no, that's the screen. It still works, but did it crash? No, not in crash, but the screen unplugged it temporarily. But that was perfect. That was that was very good. That was excellent. That was exactly right. I think the HDMI cable unplugged this. Maybe. the power. Okay, so oh. Okay, something higher like ah. Okay. So you probably don't know what don't see where this is going right now.
That's going to be musical.
No. Okay, so this is Arcanoid. I don't know when it came out, but if you say oh, it's muted. Oh, sorry. Oh, you're right. The other microphone. So now we're going to play Arcanoid. So low frequencies go left. Okay. High frequencies go right. Okay. So if you do oh all together, it should move left. Okay. If you go like ah, it should move right. Okay. And we actually managed to clear quite a few levels like this. It works really well. I need to. Okay, now I'm going to shut up because, of course, it will pick up my voice much more than yours. But just try to play. Like, again, oh, we go left, ah, we go right, okay? Because we need to calibrate it a bit for. I didn't know how loud you will be. Okay, let's try again. Let's try again. Okay, one last round and then I wrap. But just shout if it doesn't work this time. But it's really not very sensitive. Okay, last try. Anyway. So Now, with a bit more time, I'm sure we could really, like after a while, you really get used to it, and it's almost like play with hands. It's really cool. Just a couple of words, and now we did this. I mean, many of you can probably guess. So this microphone picks up what's going on, and then we do a fast Fourier transform here. And if the weighted average is below, I think 700 hertz, we go left. Actually, it's hooked directly into X windows. So now, I'm probably pressing my left key right now. Which caused a lot of problems because with other games we had letters, and I locked myself out, and I couldn't lock myself in because... But anyway, so yeah, and then we display this little graph with OpenGL just for fun, but it's really a very simple project. If you want to check out the source, okay, now I've muted. Yeah, Bitonic/speech control on GitHub, and it was me, Anders, with a lot of input from other people. Again, it's just to offset all the good stuff that you come up with. We do something stupid like this. Thanks. I would like to see Dark Souls played like this. I think, yeah, that would be fun. But no car yet, though.
Okay, so it was a quite productive weekend for number theory in Haskell. My name is Andrew, and we were working on a Arithmoy project. First of all, I learned how to pronounce the name of our package correctly. It appeared to be Arithme. And we made significant progress in improving API. I was working on making sieves, Ertos-Fan sieves, less painful to use. And Vitaly significantly disentangled square roots by modulo. We also have some new functions. Nathan made good advancement in discrete logarithm stuff. And so that's basically it. Thanks.
So, as you have heard on day one, we were going to work on a basic, which is basically takes a database search approach to manipulating data in database. And one of the things that we basically had to do in order to have a proper support is basically creating a yet another one SQL parsers. But like the end goal of this is simply like to be a front end for type-safe database model exploration. And what I mean by that, I mean it if we want to use this approach, like use our database as a single source of truth and use something as simple, as a PG dump to extract the data and then use the Haskell to manipulate it, you need some intermediary system in order to query the model schema. So like basic schema is basically a library which you can ask questions like how many columns does my table have? What are the primary keys? Is this column optional? Is it required? Does it require a maybe wrapper? And stuff like that. And of course, share is a basic, which basically takes the database first approach. As I said already, we basically use the input mainly generated by the PG dump. We then compile it to Haskell and use that to write business logic. The main idea is to have a rapid prototyping cycle. So it's something where you can start an application and get to a working state quite easily and seamlessly integrate into the existing systems, because the only thing that you have to do is, export your data, basically. Just, like a couple of lines of code to see how it's used. So you basically have your schema. You use just like a single line to parse the data and to insert it into the current file. And then you have access to a huge variety of functions that you can use in the code base to do basically wherever you want. And that's basically it. Thank you.
Short intermission. There are some lost and found items that we wanted to go through. So we have here first a nice tent, which we found on Thursday night at the lake. So who of you slept in the cold on that day? You can fetch your tent over here on the table. In addition to that, whoever lost the tent probably also lost this skateboard. So whoever then walked to this event from the Zurich Lake in Zurich, you can fetch your skateboard here on the table. Finally, probably not related to the tent, somebody lost this nice set of trash bags in an area 4 meters next to the tent. So if these trash bags are yours, then you can fetch them from the table. Okay. We actually don't know this.
Any more project demos? Thanks.
Okay, so I worked in Transity, the plain text accounting tool, and Adrian and Jan helped me. So here you can see, Here you can see the native format for Transity. So it's just like you list your commodities, your entities, which can like own money, and then you list all the transactions, how they flow between those entities, and it's YAML based. And now we wanted to have. Now we wanted to have support for HLedger, which is like the most famous and plain text accounting tool, and it has a lot of features. So we wanted to use them as well. So we built a export to HLedger. So that's the HLedger format, and now we can
can pipe it into HLedger and use HLedger's like visualization and analysis tools to better display the data. So for example, here's the balance output of HLedger, or you can use stats to show like the range of data and when the first entry was and how many entries and so on. So with the export to HLedger, it's now possible to use all the tools for HLedger to visualize your accounts and your transactions, and you don't have to rely on only those supported by Transity. Yep.
There we go. So I didn't personally get a lot done, but several people were working on submitting pull requests for DAL, improving various things. So for here, there were actually 9 new pull requests opened during ZuraHack, 4 of which were merged. One of my favorites is support for DAL being able to diff expressions. There's a new diff subcommand, which given 2 DAL expressions will now just show you a concise diff of where they differ. Another big feature which somebody's currently implementing is as location support, so that you can have a relative path in a DAL configuration file and it will resolve to a fully qualified absolute path. People were so productive that there were actually 2 people opened a pull request for the exact same feature within minutes of each other. So I appreciate both of those pull requests. Thank you very much for everybody who contributed on DAL, and also for the people who were just like learning about it and trying out on test projects. So thank you all of you who helped hack on DAL today and the other days too.
Thank you. Then we have some announcements for 2 other conferences.
Hello, my name is Yuri, and where? Oh. One moment. How's it working? Where is mirroring? In his place. Oh, finally. What? I'm an activist of Haskell community, Russian speaking and Russian located. Here is an announcement of FPConf, Functional Programming Conference. It is located in Moscow, Russia, and it happens about once a year. FPConf happens once a year. And since 2015, it is about functional programming in general. different programming languages, and this year will be the first conference about Haskell primarily. This is dedicated to Haskell. Some international speakers already presented their talks. For example, Arno Spivak. I'm not sure I'm correctly pronounce his name, and Edward Kmet gave a talk. Here is how it looks like. The main ideas: space and time, Moscow, Russia, 15th of August. About 2 months. For more information, refer to fbconf.org, fbconf.org. The registration is not open currently, but you can become a speaker and or a sponsor. If you have some questions or problems, if you get blocked by Russian language somewhere, feel free to contact me or any other contact on this website for you to find me. I know type in address. Here it is. Thank you. Please come.
Sorry. Can you use the laptop for a second just to show up?
Yeah, you can still go. Okay, just a short announcement. So I'm Andres Löhr. In 2016, we organized a Haskell Hackathon in Munich called MuniHack, which is very much inspired by Zurich Hack and is on a smaller scale. And last year we didn't manage to, but this year we're going to have another one. So it's going to be from 16 to 18 November. And it's still very early. We don't have a website yet. There is no announcement, no registration, but the date is set and it will happen. So if you want to reserve the dates on your calendars right now, 16 to 18 November 2018 in Munich, a Haskell Hackathon. Okay, thank you.
Yeah, Russian keyboard layout, this is going to be interesting. Us. Okay, yeah, hi. So I wasn't aware that plugging conferences is happening right now, but since it's happening, I might as well plug my own one as well. BusConf, the conference which doesn't take place on a bus. So it was actually inspired because I was visiting LambdaConf and we were stuck on a bus in the snow, and the thing happened that has to happen if a bus full of nerds is stuck in the snow. People start like discussing things, and it was, yeah. Someone said like, oh, it's going to be like a BusConf now, and I was like, yeah, let's do a BusConf, and this is my BusConf. It is a unconference, so I don't know, like maybe some of you know what an open space conference is. It is a bit like what's happening at the start of Zurich Hack here, when people just walk up the stage and say like, yeah, I'm going to work on this, I'm going to work on that. So basically, the idea of an open space conference is very much the same. You have like a big timetable, and people can just walk up up in the morning and say like, yeah, hi, my name is so-and-so and I'm going to work on X, Y, Z. And if you want to join me, find me in that room from that time slot on to that time. And so there's basically no clear distinction between attendees and speakers. And everyone just hangs out together and has a great time. And yeah, you're welcome to join. It's in August. Actually, right now the registration is somewhat full, but you can you can add yourself to the waiting list, and most likely you can still get in anyway, because usually people cancel, and actually there is more space available. It's just that the initial amount of rooms that I registered with the hotel is full right now. And there are no sponsors, and it's a no profit conference thingy. So if there are empty rooms, I'm going to be the one paying for them, and I don't fancy the idea of that. So yeah, add yourself to the waiting list and talk to me if you have any questions. Thank you.